Good afternoon, class, or good morning. Welcome back to MAE 205. I hope you enjoyed our lecture from last week, and I apologize that I'm not able to be with you in person this week. There's a lot of things that I want to get through in this video lecture, so there's going to be a few different videos. I wanted to keep them short and manageable. So each one should be anywhere from 5, 10, maybe 15 minutes at most for each one. So in this first one, what we're going to do is we'll go a little bit into a review of what we did last week, just into the user interface of MATLAB. We can get into some of the basic codes and operations that we learned, and then we can start getting into the lecture for today. The lecture today is going to start with a few things that you don't really need to memorize. These aren't things that you're going to be quizzed or tested on, but a few good tips when you're creating your own code. So looking at constructing a code with pseudocode. The pseudocode essentially just means partial code. It is something that you can do when you're preparing a code, for instance, where you get out a sheet of paper and you say, okay, these are the things that I know. This is the output that I want. These are some of the calculations that I'm going to use. And you can start to use some MATLAB nomenclature. You can use some of the functions that you've started to learn about, such as sine or absolute value, and start to prepare a code before you just go straight into writing a full-scale script. Then we can talk about some errors and debugging. What are the methods when you get that big red text on your screen when you think everything's perfect? The bulk of the lesson today, however, is going to be these middle bullet points here. And that's going to be working with arrays or matrices, how to operate them, the functions that we have for them to make them easier for us, how to access certain information within those matrices, and so on. And then we'll end the lesson for today on input and display functions. So these are functions that MATLAB provides us where we can get information from the user using the input function, and then we can essentially export information back to the user. So there's the display function, DISP. So when you're given a problem on a code, for example, I assign a problem to you, the very first thing that I want you to do is take a step back and say, okay, what exactly is the problem that we're trying to solve? What are the inputs and the outputs? The inputs will most likely be given to you. The outputs should also most likely be given to you, but the steps that are taken to go from an input to an output may not be. That's where you're going to determine what your algorithm is. An algorithm is just a fancy term for a series of steps or calculations to go from one thing to another. In this case, going from inputs to outputs. Obviously, within that algorithm, there may be subtasks, right? So you want to break it out into every task that's needed. Now, the first couple of weeks of our coding techniques are going to be pretty straightforward. They will be pretty short. So you may not have that many subtasks to decompose. But then we want to get into a pseudocode, and we'll look at an example of what we mean by a pseudocode. But again, it means a partial code. It's not readable by MATLAB, but it's understandable by a human in basic English terms, but utilizing some of the nomenclature of some of the MATLAB functions. So then the goal will be converting that into something that MATLAB can read. Our first lab assignment was all about learning how to communicate with MATLAB. And then, of course, we'll be testing those codes. And you should go one line at a time, sanity check the results that you're getting. Sanity check with your partners or other group members or with myself if I'm available to say, hey, does this answer look right? And then make sure that you're on the right track. So in creating a pseudocode, you can start with essentially a construct. A construct is essentially a basic command in MATLAB. You think about the commands that we learned last week, right? We learned about basic mathematical operations. We learned about how to divide and multiply and exponentiate with our caret. We also learned about how to create an array. We have to use our square brackets for an array. Or we learned how to create equations utilizing previously defined variables and so on. And then once again, your pseudocode. It's going to be a mixture of plain words and those constructs that you've created. So it's extremely helpful when you're trying to tackle a big code. I know it seems kind of obvious, maybe mundane and not necessary, but trust me, if you're given an assignment for a very complicated code, writing it out first, even the amount of parentheses that you think you're going to need for a difficult equation can be very useful. So let's do an example. This example says we want to write a program that reads an input, which means it's coming from the user, in degrees Fahrenheit. And we're going to convert it to degrees Kelvin. So there's some fancy equation for degrees Kelvin. We're going to figure out what that is. But the first thing that we want to do is take a look at our inputs. The input is going to be degrees Fahrenheit, some number that represents degrees F. So we're going to take that temperature in, and then we need to convert it somehow. So the equation to convert it is listed here. 5/9 times the temperature F minus 32 plus 273.15. So this is your pseudocode. I know it doesn't look complicated, but it just goes over the steps. And notice that there is some MATLAB lingo in here. Temp K, for instance, the variable, that is a MATLAB usable variable. The equation with the parentheses and the multiplication sign, these are all syntaxes that MATLAB can read. And then finally, we want to write that temperature. We want to give it back to the user. They want to know what the conversion is, and we want to give it back to them. So here's an example of what that might look like when this pseudocode is converted into MATLAB syntax. So it looks like a lot of lines, but remember, anything in green that starts with a percentage sign indicates a comment. And comments are entirely ignored by MATLAB. So in reality, there's only 3 lines of code required here. The first line of code says T_F is the variable, is equal to input. Now this is a function we haven't learned yet, so don't be scared that you haven't seen it. We will get into it in one of the later lessons today. But this function is essentially asking the user for information. What is the temperature in degrees Fahrenheit? Step 2, we're going to convert it to kelvins. So this is the equation for it. And all we're going to do is define a new variable called T_K, which means temperature Kelvin, is equal to some equation, which is dependent on the variable T_F. And then finally, the last line, another function that we have not learned yet, is going to be writing that information or outputting that information back to the user. So some good programming practice before we really get into some difficult ones. You want to write your program so that anybody familiar with MATLAB is going to understand it. I know we had the example last week of, hey, if your little sister or your boyfriend or your mom took a look at this code, would they have any idea what you're talking about? And probably not, and that's okay, because in all reality, it's going to be another MATLAB user who's going to be looking at your code. So you want to make sure at least they can understand your code. And you can do that by using meaningful variable names. If you define all of your variables as x1, x2, x3, well, that might make sense for you. However, if you're going back to your code a few weeks or a few months later, you might be asking yourself, what on earth is x1, x2, x3? Where if you named it, velocity underscore mass 1, velocity underscore mass 1 final, it makes a little bit more sense. Include a brief description of the steps taken. This is when your comments come in. This is why we really encourage comments on as many lines as possible. Be descriptive, right? It takes up very, very little data in your code to put some very meaningful and descriptive comments in there. Using a semicolon. Remember the semicolon after you define a variable such as x equals 3. If you run that script and you don't use the semicolon, MATLAB is going to output everything that does not have a semicolon. So add your semicolons in. That will keep them suppressed. Only remove them if you absolutely need to see that value, maybe if you're troubleshooting or using it as the output. Parentheses. Parentheses can be your best friend or your worst enemy. So I highly encourage you looking at all the different equations that were given to you in Lab Assignment 1, specifically in Section 2. Very complicated equations that require a lot of parentheses. So understanding MATLAB's readability of your parentheses is going to be a really important tool for you going forward. And if you want to add units in there in your comments, that sometimes helps as well. It's a good sanity check. If you're defining variables for velocity, for example, you may want to put that it's in meters per second. Somebody else might think miles per hour or feet per second. So, getting them. get in the habit of, naming your variables in your comments and also providing what the units are for them. It will help you downstream. Programming errors. So not all errors are going to be in big red text that you see. You're going to see big red text for only one of the type of errors, which are runtime errors. But let's talk about the first one, syntax errors. So when you're writing a script, you may notice at the top of your screen, there's a little green check mark. Let's take a look at it real quick. I'll open up my script editor here. And notice on the right side at the top, there's this green check mark. It says no warnings found. Well, if I start to write code, suddenly I might get a little squiggly line. And there'll be a little orange or red line here indicating, hey, the MATLAB compiler has seen something that might cause an error. Now, if you get a red warning sign, that essentially means that this code will not run. There is an error that MATLAB cannot understand, whereas an orange squiggly line essentially means here's a warning. Your code is going to run, however, here's a way to improve it, or maybe this is what you were thinking. Regardless, understanding these syntax errors can be very beneficial for you. And all this one's asking for is to add a semicolon. And now it goes away. Then you have a runtime error. A runtime error is when your code cannot be read entirely by MATLAB. MATLAB's missing something. Maybe you're asking for a variable to be used that hasn't been defined yet, right? These are going to be the red text you see in your command window when you try running something that doesn't exist. For example, if we go into the command window here and we say x is equal to 2 times y, well, MATLAB doesn't know what y is. Y does not exist in the workspace. This is known as a runtime error. And then finally, a logical error. The logical error is readable by MATLAB. MATLAB's not detecting any errors. However, you're not getting the right answer. This might mean that your parentheses are in the wrong spot. Maybe you're using a plus sign instead of a minus sign. Maybe you're using backwards division in front of forward division. So unfortunately, logical errors are the hardest to detect because MATLAB does not detect them for you. Now, I often tell students that programming is 10% writing script and 90% troubleshooting. You will get a lot of errors. Now, how do you go about fixing these errors? Well, my first recommendation is to look through your script one line at a time, right? Go through each variable, each calculation, or each function that you've listed, and remove the first semicolon. Check your answer. Does it make sense? Is it at least within range? Then go to the next one, and so on. Consider breaking your statements into smaller ones. If you have a really complicated equation, for instance, maybe you just want to do small pieces of that equation, just to make sure that you're on the right track. Always check your parentheses are in the right spot. Make sure your variables have been initialized properly. This is really, really key. The example we just looked at, we tried to say that x was equal to 2 times y. And MATLAB came back with a runtime error. It did not know what y was. Y has to be defined in your script. And not only does it need to be in the script, it has to be before the line that it's used. MATLAB reads code one line at a time. So if y is not defined in line 1, when it's used in line 2, it's not going to be there. It's going to get a runtime error. Check the units for your functions. Maybe there's a conversion that you need to make. Maybe you're using, again, meters per second, and it needs to be in feet per second or something else. And then there's the debugger, the symbolic debugger. So feel free to go into chapter 3 of the book and take a look at that.